Hello everybody, I'm Brainy Diode, and surprise, I'm actually not dead. Today I'm here to bring you another episode of How to Build a Time Machine, as you could probably already tell. Today, we will be discussing how to enter the time vortex, expanding on some ideas that I brought up in the last video, and I'm also proposing some new ones. So without further ado, let's just get going. So after I completed my discussion of higher dimensions and their necessity for time travel, I did some research to find out if there are any prevalent theories relating to movement in the fifth dimension. Unfortunately, I wasn't really able to find too much, considering the fifth dimension is still a mathematical abstraction, meaning that we really don't know much about it. I did, however, happen to stumble upon a somewhat recent development relating to multi-dimensional travel, in the form of the Large Hadron Collider, or the LHC for short. No, I'm not going to be talking about black holes, at least not in relation to the LHC, but there is another possible phenomenon, including the machine, that ties very closely to what I talked about in the last video. So for those of you unaware, the LHC, the Large Hadron Collider, is a giant ring of tubes located beneath the border of France and Switzerland. It consists of about 17 miles of tube, making it the largest machine ever constructed. Its job is to shoot particles at each other at over 99% of the speed of light, which, in case you weren't aware, is pretty darn fast. And they want to see what happens when they collide. Now, some scientists speculate, and try saying that 5 times fast, that such powerful collisions could cause bits and pieces of particles to be flung in every direction, including those not involved or not included in our four-dimensional space-time. Should this occur, the ripples set off by such a phenomenon would register with the LHC's instruments as an increase in mass, which is a clear violation of the law of conservation of mass. Now, as of yet, no experiments have yielded such results, but that doesn't necessarily mean they're impossible. There is, however, one very obvious problem. I, for one, have no desire to be flung at a wall or something else at more than 99% the speed of light, only to have a part of me travel in time. So, is that it? Do we have to wait even more decades, perhaps even centuries, for some revolutionary form of fifth-dimensional travel to be created? Now, I'm sure you've guessed by the answer by the amount of time left in the video. You see, I may have been slightly off the mark last time. According to some sources I've found since then, we don't need to have objects such as time machines travel on their own through the fifth dimension. So the idea of this independently moving TARDIS that I proposed in the last episode isn't necessarily completely accurate. I mean, it would be a cool idea, but it turns out it may not be completely necessary. You see, all you need to do is bend the first 4 dimensions through the 5th dimension, altering the very structure of the universe to fit your own needs. And that probably sounds even more ridiculous than LHC-based time travel, but the really crazy thing is that we're already doing it, just not to the scale needed for what we think of as time travel. It all goes back to a fun little thing called gravity. Just to clarify, I'm not talking about the movie. I'm talking about what many people would probably refer to as an attractive force between 2 objects, such as 2 planets or other celestial bodies. Some people may even include in their definition that people also have a gravitational force, as well as really anything at all, just not nearly as strong as the forces we experience from said heavenly bodies. But the thing is that while that answer is fine for day-to-day use, it's really missing a lot of mechanics that we need for a lot of scientific ideas, such as this one. You see, according to Einstein's theories, space and time are inextricably linked in a four-dimensional construct we refer to as the fabric of space-time. Imagine this piece of paper is the fabric of space-time. If I were to place any object on top of it, for example this marker, it would create a bend. And the heavier the object is, the bigger the bend would be. And the closer an object is to that bend, the more likely it is to fall into the bend, producing the force we know of as gravity. Now, I apologize for that demonstration being a little bit off. Paper is kind of weird. Markers are way too circular for this sort of demonstration. I really could have thought that through better. But the point is, gravitational forces are actually that bending of space-time. And the whole idea of space-time being inseparable might seem insane, but a very important discovery occurred less than a year before the creation of this video that proves, almost beyond a shadow of a doubt, that the fabric of space-time really does exist. And that discovery is known as gravity waves. You see, Einstein predicted that large enough gravitational force would send ripples through the fabric of space-time, and you may not be able to see the ripples too well thanks to the slow-moving nature of my dang webcam. But they're there, I promise you. Obviously, you can't see the actual ripples in space-time in real life, or else everything would be rippling around us all the time, probably. So maybe the demonstration was a bit more accurate than I anticipated. But, moving on. In February of 2016, a team of astrophysicists announced that the collision of two black holes 1.3 billion years ago created conditions identical to those predicted by Einstein's theoretical gravitational wave calculations. Try saying that 5 times fast as well. This means that space-time is a fabric, that it can be warped, and that Einstein's calculations allowing for time travel are plausible. If I were to place a heavy enough object on this sheet of paper, ignoring the fact that the paper would probably rip, the paper would be drawn down so far that the two edges would be brought together like so, creating a sort of bridge. If you've ever read the novel A Wrinkle in Time, this is exactly the phenomenon discussed that allows the characters to travel through space so quickly. Since the fabric of space-time includes time as well as space, a carefully placed force of extreme gravity could theoretically allow you to travel from a specific point in time to another specific point in time. But how do you get such a powerful gravitational force? Well, some scientists suggest that some supermassive black holes may exert the gravity necessary for this sort of event to occur. Suddenly, the ending of Interstellar doesn't seem so crazy. This is what creates a certain theoretical construct that you've probably heard of, the wormhole. Since we're discussing time travel here, you might want to call it a time hole instead. And because matter spirals down into a black hole like water goes down a drain, you would not be stepping out of line to refer to it as a time vortex. Does that sound familiar to anyone? We don't really see the Doctor jetting off to the nearest black hole whenever he travels through time, though. Besides, black holes will pretty much only link you to other specific points in space-time, so they don't allow for the freedom that the TARDIS enjoys. Well, the Doctor does, however, have an easy out with this one, since we do have canonical confirmation that the TARDIS is infinite in mass. The Doctor could easily create the gravitational bending needed for time travel anytime he wants. Unfortunately, we humans have a notable lack of infinitely massive vehicles, so how do we pull it off? Well, perhaps the most famous mathematical equation proposed by Einstein states that energy equals mass times the speed of light, that's represented by the variable c in this situation, to the second power. Wow! My upside-down writing skills are a lot better than I thought they were. But, moving on, if we shift around some variables, thanks to fun algebra rules, we get an equation defining mass, let's see if I can repeat that phenomenon, defining mass as equal to energy divided by the speed of light to the second power. So the easiest answer here is to get infinite mass out of this equation, just plug in infinite energy, which, thanks to the pesky rules of inertia, happens to be exactly the amount of energy needed to accelerate a physical object to the speed of light. So, just shoot something faster than the speed of light and you're good, right? Suddenly all those episodes of Star Trek don't seem so crazy. Well, the answer to this question is, well, maybe? You see, there are two very obvious problems with this solution. One, where are you going to get the infinite energy necessary to pull this off? And two, this equation only yields infinite mass if you ignore the fact that infinity is not technically a numerical value and therefore is not really divisible by anything. Since mathematics is really the only constant we're working with here with all this abstract science stuff, ignoring rules like that is really out of the question, since we should really be clinging to every little bit of evidence we can get. Again, the Doctor has an easy out because he literally has an entire separate universe stored inside his TARDIS, but we humans still have yet to figure out how to pull that off. So, it looks like we're stuck again. Look on the bright side, though. At least we figured out how the TARDIS travels instantaneously through time and space, which is a very necessary first step. So, we've hit another roadblock. Never fear, though, because this series on time travel isn't over yet. Join me next time when we'll explore the nature of time paradoxes and how they can be avoided. Until then, feel free to check out any of my other theory videos. They're less scientifically involved than this one, don't worry. And please visit my channel in the future for more facts, theories, and ideas. Thanks for watching, and I'll see you next time.